Here we have a related rates problem for you to try yourself. This is a DIY problem. Let's take a look. Allison and John are driving away from Danny's, so here's Danny's, at 2 p.m. Alice is driving north at 25 miles per hour, and John is driving east at 30 miles per hour. And we're asked, how fast is the distance between them increasing at 2:30 p.m.? So let's call that distance S. Might seem reasonable to call it D, but when we start taking derivatives, you'll see why that's not such a great choice. I'm going to pause the video, give you a chance to do the problem, and then resume with some hints in case you need them. Let's go ahead and label some of the other things in the picture. First of all, we see that we have a right triangle in here, so it's going to make some sense to use the Pythagorean theorem. Well, let's call the distance, I guess that is John's distance from Danny, let's call that X, okay, and let's call Allison's distance from Danny Y. And so what do we actually know here? Well, we know that Allison's distance is increasing at the rate of 25 miles per hour, John's at 30 miles per hour. So those are related to derivatives, but first of all, we know that x and y are related by the Pythagorean theorem. So what is that? Well, that is that x squared plus y squared is s squared. So using that, it's now makes sense to go ahead and do some differentiating and use the things that were given in the problem. Well, the next thing we're going to do is take the derivative with respect to t on both sides of the equation. So we have this. And let's go ahead and do that. We have 2x dx dt using the chain rule, because x does depend on t, plus 2y dy dt is equal to 2s ds dt. And several things here are known. We know dx dt, we know dy dt, we want to know ds dt, but what about x, y, and s? Well, that's where we have to use this information about 2:30 p.m. So I'll pause the video and give you a chance to think about that, and then we'll resume. So at 2:30 p.m., what's happening? Well, that means that t is equal to 1/2 hour because Allison and John left Danny's at 2 o'clock. So we need to know what this right triangle looks like when t is equal to 1/2 hour. Okay? So we know that John is traveling 30 miles per hour. So after 1/2 hour, he will have gone 30 miles per hour times 1/2 hour, which is 15 miles. So this will be 15. And what about Allison? Well, she's going 25 miles an hour. So 25 miles per hour times 1/2 hour is going to be 25 halves miles, okay, or 12.5 miles. So this is 12.5. Now we have to determine s, and then we will know everything we need to solve for ds dt. So I'm going to stop and let you try and find s and finish off the problem. Using the Pythagorean theorem, we have that s squared is equal to 12.5 squared plus 15 squared, which is, using our calculator, 156.25 plus 225, which is 381.25. So s at 2:30 will be approximately 19.53, and that's miles. So now we have everything we need to fill in our formula and solve for ds dt. Now we have all the missing pieces. The first thing we want to do is cancel all of these 2's. We can divide both sides by 2. And let's look at the right-hand side. We have s ds dt, so that's 19.53 ds dt is equal to x, which is 15, dx dt, which is 30, plus y, which is 12.5, and remember dy dt was 25. Now we have units on all of these things, but let's go ahead and divide both sides by 19.53. Everything here gets divided by 19.53, and I'll pause and let you finish the. Completing our problem, we see now that ds dt, that is the rate at which the distance between Allison and John is increasing, is going to be 450 plus, and if we do the multiplication, we get 468.75 divided by 19.53. This is approximately. And we get 918.75 divided by 19.53, and that is approximately 47.04. And let's just check units here. This is feet, remember, or sorry, miles, and this is miles, and this is miles. So the miles cancel, and these are miles per hour and miles per hour. So we get miles per hour, and that is the speed with which the distance between them is increasing.